All right, so this is our last transformation, and this is where we shift the function to the left and to the right. And that's where inside the bracket with our x, we either add or we can subtract that value of d. So to begin with, just to sort of explain about why it kind of works. Again, as per, I've got my little sine wave going on there, and I know my sine 90 equals 1. Now, let's think about what happens if to my x, I was adding, let's say, 30. So if I still wanted to make the 1 in the end, that means in the bracket, I want that entire thing to equal 90. So that means I need to have 60 plus 30, because 60 plus 30 is going to give me the 90, and that will equal 1. And essentially what that means is I will take my function, so I would take my wave, and I would need to push that back by 30 degrees so the x value matches up. So what would have been roughly my 60 degrees here, that is now where my 1 is. So it kind of goes in the reverse of what you expect. If we are adding on to our x, that means the graph is going to go to the left. However, if we subtract, then our graph goes towards the right. So let's take a look at a few examples of how that works. So here I've got sketch the graph y equals sine x plus 20. So to start off with, I'm just going to draw my normal sine wave as per. So there's my sine wave. And then, so it normally crosses through at 180 and 360. The 1 and the minus 1. So because I'm plusing 20, that means I want the graph to move backwards by 20. So in this time, it's probably actually easier. Normally I prefer doing the wave and then putting in the numbers, but it's probably easier to make a note of what the numbers are. So 180, I'm going to take away 20 from it. So I've now got 160, and then my 360, I'm going to take away 20 from that to give me 340. And my wave is going to start behind the graph. So somewhere behind, that's going to be my minus 20. Because normally I start at 0, but now I'm starting at minus 20. So you have to sort of imagine the initial increase. And then we go up and down through the 660, up through the 340, and then I just have to do that little bit more to make up that 360, because we want that extra 20 degrees on the end. And I've got the 1 and the minus 1. It's the same idea for this next one. So sketch out my normal cosine wave. So 90, 270, 1 and minus 1. So that's my normal cosine wave. I'm just quickly going to make a note up here. That's our sine x plus 20. So now we want to do our cos x minus 5. So this time the whole graph is going to go to the right by 5. So I need to imagine my axes. So typically I go through the graph at 90 degrees, but I'm going to add on 5, so that's going to be 95. And I'm going to add on 5 to my 270, so that's going to be 275. And also I'm going to start slightly off to the right. So I start up here, down to the 95, round, through the 270, and I'm going to sort of hit a point because I'm not going to quite be able to make that curved lip over. And I need to sort of correct that last bit just beforehand to make sure it's going from the 0 mark. So I had to add in this little bit to the beginning of my curve. Because remember, at that point, that's now starting at 5 degrees. Okay, let's take a look at another one. So here I've got y equals 8 cos x plus 10. So first, drawing out our cos wave. So there we go. 1 minus 1. That's at 90 and 270. Then I'm going to draw my 8 cos x, because that's a little easier to tackle than the other one. So all it's going to do is make that 8 and that minus 8. And then we want to do our 8 cos x plus 10. So remember, because it's plus 10, it's going to go off to the left, so it's going to shift backwards. So I've got to think, right, 90 take away the 10, so it's going to go through 80 now. 270 take away 10, it's now going to go through 260. And you got to remember, because the whole thing's shifted back, that start point has probably gone a bit behind the line. It's going to already be dropping down. So it's going to be dropping down through the 80, round. And I'm going to slightly go over, because remember the end point, that's the whole thing needs to be pushed back that tiny bit. And so I'm going to have my max of the 8 and the minimum of minus 8. Okay, last one here. I've got y equals sine 2x minus 5. So again, going to sketch out my sine x graph. So there it is, going through 180 and 360. So that's going to be 1 and minus 1. So then I want to do my sine 2x, because now I'm in the bracket, I definitely have to do the multiplication first. So remember, that's the same as me saying it's going to fit in the 360 degrees twice, because 360 divided by 2 is 180, which is the new period. So it fits in once, fits in twice. So halving that's going to be 90. That'll be 180, 270, and 360. Sorry, I was a bit squished there. And 1 and minus 1. So now I can do my sine 2x minus 5. So that means everything is going to shift slightly to the right. So it's going to start slightly off, and then it's going to go off to the right. So 1, and then probably cut fully, just a little bit off before it gets there. So that starting point, I've had to add on 5 because originally I started 0. So now I'm starting 5 paces in. So that's going to be 5. That'll be 95, 185, and that'll be 275. I'll just need to bring that down a little bit as well. That will still be 1 and minus 1. So that's the sketching part of it. So let's take a look at someone we have to identify it from the graph already drawn. So we've been told the following graphs show the function y equals a sine x plus d and y equals a cos x plus d in the interval 0x to 360. State the value of a and d. So for these ones here, the first one, we've got a cos wave. And these ones I have stated which type of wave it is, because obviously cos and sine are quite similar. It does actually make a difference on how you might look at it. You might look at it differently. So I've made a point of this first one is a cos wave. So this is where everything should normally be going. So start off with my amplitude. That is the easiest one. From the midpoint to the top, that is going to be 3. So that means my amplitude is 3. And then thinking about how it's shifted, typically I'm going to be going through 90 degrees, but I'm now going through 50. And typically that should be saying 230 there. And then typically I should be going through 270 degrees, but now I'm going through 230. So what I've done, to go from 90 to the 50 and 270 to the 230, I've gone back by 40. But remember, because I'm going backwards, that means it's a positive 40 degrees. Okay, let's take a look at question 2 then. So question 2, my amplitude is that 15 there. So A equals 15. Then I'm being told it's a sine wave, so let's just take a look at our normal sine wave. So this time, normally I start at 0, but my wave starts to begin here at 10. And it sort of gets cut off before the end of that 360. And then normally I pass through 180, but here I pass through 90. So we can see I've kind of added on 10 to the whole thing. So it's gone to the right by 10, so that means I have to have minus 10 for my D. Then my last 2 examples here. So these are probably one of the toughest ones. So we're told the following graphs show the function y equals sine cx plus d and y equals cos cx plus d. State the value of c and d. Now for these ones, it is kind of a bit of being able to just spot the patterns, being able to sort of spot how it is guiding you. So to start off with this question 1, we're kind of given this sort of distance of the 360 degrees. So I need to kind of imagine how many sine waves can I fit in that 360 degrees. So let's just sort of imagine the previous wave. It's starting, and there's my first wave, and then here's my second wave, and I'm just going to ignore that sort of bit on the end because I thought about the bit at the start. I've been able to have the wave fit in twice, so that means my C is going to be 2. Because I've been able to fit it in twice. And so I want to quickly draw out what sine 2x looks like. So I can see how did it shift from the 2x part of it. So remember, that means I'm going to divide the 360 by 2. So one wave is 180. And that means in the middle there, that's the 90 degrees. So I've gone from 90 to 80 and 180 to 70. So I've gone back by 10 degrees. So that means my D is going to be a positive 10 degrees. And then let's take a look at question 2. Now this time I can't go to the 360 degrees. I've only gotten up to this 120. But that kind of gives us a clue that maybe I want this one wave to originally fit into that 120. And if I was to divide 360 by 3, that would give me 120. So C here equals 3. So then I do a similar thing. I think, right, let's remember my original cosine wave. So normally I pass through 90. 90 divided by 3 is going to be 30. And 270 divided by 3 is 90. So that's my cos 3x. So what's happened now? I've gone from the 30 to the 45 and the 90 to the 105. And what I've done in all those cases, I've added 15 degrees. So I've gone to the right by 15. So that means I take away 15 degrees. So definitely the most confusing part about this is that it is the reverse of what you expect. If it's a positive, it's going to the left, it's going backwards. But if it's a negative, it's going to the right, it's getting bigger. Let me know if you have any questions and good luck with the work on this.